Today we're going to go over the law of conservation of momentum. So the law of conservation of momentum says the total momentum of any groups of objects remains the same unless outside forces act on the group. So this happens when two objects are involved in an action-reaction collision. So what we're going to be dealing with today are collisions. Now, the collisions that we're going to be dealing with today are somewhat simple, where they're going in, let's say, one line. What I mean is they're not going off at angles. That's what we're going to do next week. And what happens is the angles, then we have to go and use like sine, cosine, tangent, or whatever, looking at the angles. But we're not doing that today. So basically what it says is, in layman's terms, the total momentum before is equal to the total momentum after. So if we look at that, the total momentum before is the total momentum after. That's how you're going to think about it. Now, however you want to identify different objects, I think your book identifies objects as like 1 and 2. I sometimes identify objects as A and B. And let me just tell you my notation, and the book does a little different. I don't like to use a double subscript. So what do I mean by a double subscript? Well, if I had the total momentum before, so my objects are A and B. So you notice here, PA and PB, this represents the momentum of object A before collision, and this is B. A double subscript would mean your book does P1I plus P2I is equal to P2F, P1F plus P2F. So that's what I mean by a double subscript. I don't like double subscripts. I think it makes it confusing. When you start having ones and I's, don't they start looking the same? It starts to get it confusing. But you do what's best for you. So if that's the notation that you understand and that's what you want to do, that's fine. What I do is I usually, for momentum, I call objects A and B, so I don't mix up the letters and the numbers. Then to distinguish before collision from after the collision, it's hard to see here, I put a dash like this and I call this prime. So the total momentum before is the total momentum after, and the difference is I call this prime. But again, you do what you want. So I know what I learned before is momentum is mass times velocity. So if I want to know the momentum of object A before collision, it's going to be MAVA. The momentum of object B before collision is going to be MBVB. After collision, does the mass change before or after collision? No, the mass stays the same. So the momentum of ball A or object A would be VA prime, and this would be VB prime. Okay? So the masses don't change, just the velocity. Now we have different types of collisions. Inelastic means the objects stick together and move off with one velocity. So what do I mean by that? Well, what that means is, let's say you have two cars and they crash, and their bumpers interlock, and then after the collision they move off together. Okay? That's what's called an inelastic collision, because they stick together. Okay? Another example is, and they use this a lot of times in physics book, is somebody shoots a bullet into a block, and the block becomes embedded in, the bullet becomes embedded in the block, and then the bullet and block move off together. Okay? Now, this is not an equation you have to memorize. So let's say that I have my basic equation for momentum, MAVA plus MBVB is equal to MAVA prime plus MBVB prime. So if two objects stick together and they move off with the same velocity, that means this velocity is equal to this velocity. So instead of calling them individually VA prime and VB prime, I can just call it V prime. Then, if I have MAV prime plus MBV prime, because remember, they're stuck together and this is the same velocity, can I then simplify the terms and say MA plus MB times V prime? Does everyone see what I did here? So what's happening is I'm not making up new equations. When I remember, me personally, when I remember my equations for momentum, I don't say MAVA plus MBVB plus MAVA prime. I don't remember them like that. What I do is I think in layman's terms. I say the total momentum before is equal to the total momentum after. And if you know momentum is P, and I know P is equal to M times V, and that's it. So we're just using the definition of momentum and just saying with conservation of momentum that the total momentum before is equal to the total momentum after. So inelastic is where they stick together, okay? And if you want to write examples there, again, like bumpers interlocking in a car, a bullet embedded in a wood block, or you just write in your own words where they stick together and they move off with one velocity. And elastic, now when I think of the word elastic, I think like stretchy. Okay, like a rubber band. So an elastic one is where two objects combined and they bounce off each other. They bounce off each other, and then they each go off with their own individual velocity. So again, there's the prime here. When I type this in math type, I know now better that prime came out to be small. But so this is again just like the conservation of momentum, MAVA plus MBVB is equal to MAVA prime plus MBVB prime. So in cases like this, and what we're going to do today is we'll be giving everything except one variable because we're just starting off and they're somewhat simple. Okay. So let's look at our examples. So the first example says a steel glider of mass 0.5. Now what happens with momentum is, you see how you have you're going to be given a lot of stuff? To make sure you don't make a mistake, when you're reading the problem, chunk the problem, and as you read each variable, write it down. So it says a steel glider of mass 0.5 kilograms. So before I go on, I'm going to write down that, and here I called it 1, M1 is 0.5 kilograms. Moves along an air track with a velocity. So this velocity corresponds to this mass, so if that's M1, that's V1. It collides with a second steel glider that's mass 1 kilogram, so I'm going to write the second mass, moving along in the same direction. Now, if it was going in the opposite direction, I would have to make it negative, because velocity is a vector quantity. It has both magnitude and direction. Momentum is a vector quantity. It has both magnitude and direction. You have to be extremely careful with your signs. So if it's in the same direction, if this is positive, this is positive. If the problem says it's going in the opposite direction, then I need to make it negative. We're still going to use our standard Cartesian sign convention. So we'll call right positive and left negative. After the collision, the first glider continues with a velocity of 0.35 meters per second. What is the velocity of the second glider? So again, it's important to write your given. So this second velocity, I called that V1 prime. So this denotes the velocity of the first glider after collision. So what I do is I always think of it in terms of layman's terms. The total momentum before is equal to the total momentum after. The total momentum before is the sum of glider 1 and glider 2. And then this is the momentum of glider 1 and glider 2, but the prime indicates after collision. So now I'm going to expand that out. I know P is equal to MV. So P1 is M1V1, P2 is M2V2, P1 prime is M1V1 prime, and P2 prime is M2V2 prime. Instead of just plugging in numbers, when you just plug numbers in, that's how you make a mistake. So what you need to do is rearrange the equation to solve for the unknown in terms of the known. So I'm solving for V2 prime, so I'm going to rearrange this, and this is really simple. When I'm solving for something algebraically, I'm going to leave it where it is on one side of the equal sign. So I'm going to leave V2 prime where it is. So because M1, V1 prime, because there's a positive here, I'm going to subtract it from both sides. Then I'll have M2, so I'll divide everything by M2. Now I substitute in my values, and then when I substitute my values, I can easily find V2 prime, and I forgot the prime there. Okay. And that's it, because our next example has to do with what we're going to learn in a subsequent lesson. And that's it.